Okay, let us see this question. Three resistance wire X, Y, Z. So basically these are the resistance. We can mark this as this. Okay, there are three resistance wire X, Y, Z made from the same material, so their resistivity are same, are connected to each other and to a circular plastic ring as shown. And this is the plastic ring, so this is not a conductive. So this is the plastic ring. Okay, wire X and Y each have twice the diameter of wire Z. Okay, so X, Y, and Z. The wire X and Y have each twice the diameter of Z. So let us talk about the diameter. So if the diameter of Z wire is D, I'm considering the diameter of wire Z as D. So the diameter of Y and X should be 2D, right? According to question, wire X and Y each have twice the diameter, right? Wire X is 12 centimeter long, and so if we talk about the length, so wire X is 12 centimeter long, wire Z is 15 centimeter long, and is connected across a diameter of the ring. Okay, see, the first statement is only for X, the second is after that we have the full stop, so it's separate. Now the wire Z is 15 centimeter long, so we get this one 50 centimeter long, so it means we have the diameter, so we can have the radius of this circle as well, and it's connected to the diameter of the ring. You can see here, this is the wire Z. I can name this as AB, right? Is it okay? Now a power supply is connected to the
Yes.
two corners of the triangle that lie on the diameter. A power supply is connected to the two corners of the triangle that lie on the diameter. It means the power supply should be connected in this manner, isn't it? Let us read it again. See, the power supply is connected to the two
Yes.
corners of the triangle. See, basically there are three corners, but we have to consider two corners, and those two corners of the triangle that lie on the diameter. So it means I have to apply the power source across A and B. It's very simple, isn't it? What is the value of the ratio of current in X and current in Z? So now we have to find current in ratio in current of Ix upon Iz. Okay, so Ix and Iz. Okay, so let us first name it as C. Do you have any idea how we can proceed?
Sir, do the normal series and parallel circuit rules apply in this case? Because then the voltage, because if the voltage in X and Z are different, does that mean the voltage would also be the same in X, Y, and Z?
Let us suppose I have applied a voltage V here. Let us suppose I have applied a voltage V here. So what we need? See, across AB, you have a voltage of V, no problem, because in parallel, and the total voltage across ACB. Okay, let me modify this circuit. This will be very easy for you. See, this is the resistance AB, and in the upper part you have this, and this. Please try to understand. This is the again A, and this is the C, and this is the C, and this is the B, isn't it? And you have applied a voltage across this AB. Please analyze that this circuit is the same as in this form. Are you getting my point? Let us suppose this is the RZ, this is the RX,
Yes.
and this is the RY. Are you getting that? Both are representing the same situation. This is very important for your understanding. This is the RX, this is
Yes,
the
sir.
RY, and this is the RZ, and they are connected in this manner. So the voltage across this RZ is still plus V, isn't it? Right? Any problem?
Yes, sir.
No. See here, for solving this question, we need the relation between the resistance of XYZ. And you know what's the formula for resistance? R is equals to rho L by A, isn't it? R is equals to rho L by A. Do you know this or not?
Yes, sir.
So now we have given that rho is same for all.
Yes, I learned that.
Yeah, rho is same for all. So if we want to find the ratio of the resistance, we have to consider only the ratio of L and A. We have to consider only the parameter L, that is the length of the resistance, and A cross section area. For the cross section area, we have the information about their diameter. Please see. For the cross section comparison or the ratio, we have the diameter, but for the length, for the comparison of length, we don't have the length of all these resistors. Are you getting my point? You have the length of this X, you have the length of this Z, but you don't have the length of this Y. So first try to find the length of Y. Are you getting my linking? How I'm linking? See,
Sir,
first, yeah,
yes, we can use Pythagoras theorem to find the length
yeah,
of
very
Y.
good. Since this is the
Because
diameter,
in a
so here it will be a 90 degree, right? So this is the 15, this is the 12. So please find this BC according to Pythagoras theorem. That's very good. You are going in the good direction. Yes, please find what it should be BC according to Pythagoras theorem. So what do you do? 15
It's
square.
9 centimeters of.
Yeah, so it is 9 centimeter. So now you have this 9 centimeter. Now we can have the ratio of x is to y is to z, resistance. Suppose we want to find ratio of resistance rx ry, anything we can do, no problem. Okay, so right now I want to find the ratio of x rx and ry. Let us find it. We want to find that, why? Because see here. So you can see the total voltage between a and b in the upper branch. The total voltage between a and b in the upper branch is still v. Its total voltage is v, but I want individual, how much for rx and how much for ry. It means I need the voltage division here. So to do the voltage division, what I should have, the ratio between rx and ry. So now I'm writing rho L of x. I think we should take this question on the, you know blackboard. Here very little space. Okay. Okay, so what we are finding here, see, we are trying to find the ratio of rx upon ry. So I should write rho L of x upon rho L by a. So a of x upon rho L by L of y upon a of y. So this rho and rho will be cancelled out. So you will have L of x into a of y upon L of y into a of x, right? You know what is the Lx and what is the Ly. Lx, length of x is 12 centimeter, so write it 12 centimeter. L of y is 9 centimeter, so write it 9 centimeter into a of y, area, that is the pi r square, that is the pi. You don't have the r, so it means d by 2 dy, that is the diameter, by 2 whole square. Similarly, area of x, you don't have the radius, no problem, pi dx by 2 whole square. Is it okay? See, this pi and pi will cancel out, so
Yes.
this centimeter will cancel out, so you will have here 3 4 ja 3 9 ja. So right now we are getting 4 by 3 in this, and this 2 and 2 will get cancelled out. So here you will have dy upon dx whole square, isn't it? So now we have 4 upon 3
Yes, sir.
into dy. What is the dy? Dy is same 2d, and x is also 2d. Both diameter are same. See here, initially even both have the same diameter. So square, nothing, no problem. So still you are getting the ratio as 4 is to 3, right? Now you got that the ratio between x and y. So rx is to ry is 4 is to 3, isn't it? Are you getting this?
Yes, sir.
So now see, the complete AB branch has voltage V. The complete AB branch in the above side has the voltage V, right? Now I have to divide how much for X and how much for Y. So I have to apply the voltage division rule. What's the voltage division rule is? V equals to IR. See, X and Y are in series, RX and RY are in series. In the series, current is common, same. So I should be ignored. So now we have the relation between V and R. They are directly proportional. So now I am finding the voltage along X, voltage in Rx. So I should write Rx in the numerator. So the ratio is 4. 4 upon 4 plus 3 into the total voltage, that is the V. So Rx should be 4 upon 7V. So the Rx has the voltage of this much. Suppose you want to find along Y. So what's the proportion of this Ry? It is 3. So it should be 3V upon 7, right? So now you have voltage along all the resistors. Along Z, it is V. Along Rx, it is 4V upon 7. Along Ry, it is 3V upon 7. Is it okay?
Yes, sir.
Now we have to find the current in X. Now we have to find Ix upon Iz. Very simple. What is the Ix? Current in X resistor. So what it should be? According to Ohm's law, V upon
Should be
R.
RX or
Yeah, which V? So
RX.
Vx means the voltage across X upon resistor of X. So this will give you the Ix. Iz. Which I? Which V? So Vz, it means voltage across Z upon R of Z, isn't it? So when you will simplify this, we will get
Yes.
Vx upon Vz into Rz upon Rx. Are you getting this? Now you have the Vx.
Yes, sir.
Vx is 4V upon 7. This is the Vx, and Vz is V itself. Vz is V. I have written here many times, into rz upon rx. Now I have to find the ratio between rz upon rx, just like we have find it rx upon ry. Now we are interested in rz and rx. So now I have to find rz upon Rx. So let us do the same thing here, Rz upon Rx. So it should be rho L, that is the Lz upon Az upon rho Lx upon Ax. So this rho will cancel out. So you will have Lz into Ax upon Lx into Az. See Lz, we have the Lz, yeah, that is the 15. I'm ignoring the units here. Lx is 12, so write it 12. And similarly, see, I have shown the previous calculation that how your Ay, Ax should be calculated here. So I am ignoring the basic calculation. I'm just taking this d like a ratio of the diameter. So I should have dy upon d, yeah, so I should have here dx upon dz whole square. Are you getting this? I have written directly here because I have already explained in full detail earlier, right? So now just put the value, you can simplify it, 3 5s are 3 4s are, so it is 5 upon 4 times dx, diameter of x was 2d. See, diameter of x was 2d and diameter of z was d. So keep this and take the square, cancel out. So 2 2s are 4, right? So this can be also be simplified. So this is the 5. So I should write here 5. So right here 5, this v can be cancel out. So you are getting 4 upon 7 into 5. So it should be 20 upon 7. Let me see. Yeah, correct. Tanuka,
Yes,
have
sir.
you enjoyed this
Now I
question?
understand. That was a particularly challenging question.
Yeah, but we have done. See, this question has a lot of linking. Everything should be properly linked. Then only you can solve it. Everything, maths, physics, everything, Pythagoras, everything is linked in this question. So this is a very good question, right?
It was initially hard for me to visualize because a circuit isn't usually arranged in a triangular format.
Okay, okay, no problem. See, basically, I have many corrections also in which you will get some. If you want, I can discuss that another question also here. Please see, right? Can we do next?
Okay, sir.
Suppose question is saying I have a long wire whose resistance is 12 ohm, right? I have a long wire whose resistance is 12 ohm. It is bent into a form of circle. It is uniformly bent into a form of circle. What will be the current if I, and see, you have some geometry dotted here. Suppose I have applied a voltage source between these 2 points A and B. Suppose I have applied a voltage source between these 2 points like this, a voltage source of, you can say, 36 volt. So how much current will flow in this circuit? You have to find the current in this circuit. Are you getting the question statement? See, I have a long wire of resistance that
Yes.
has 12 ohm, right? It is bent into a form of circle shown in the diagram, and I have applied a voltage source between the points A, B. You have some other points as well, C, D. So I have applied a voltage source across the A and B. What should be the current in this circuit? You have to think, just think, then we will move.
So first should you find the total voltage by divide the total current in the
Yeah, I have to find the total
uniform
current only. I have to find
circle.
the total current. Yeah, no, see, I have to find the total current. See, how much current start from this battery. That's all. Nothing more. Please try.
So would it be 3 amperes?
3 amperes. How? Okay, see, Sanuka, I think most probably it should be incorrect. See, I don't know the question, I don't know the answer. I just framed this right now. See, but most probably your answer will be incorrect. Most probably. You know why? First of all, see, this complete wire has been formed in a circle. So the resistance of this complete circle is 12 ohm. So see, you can see here that it is shown AB is a 1/4 part of the circle. AB is a 1/4 of the circle. See, AB is a 1/4 of the circle. See, this is also 1/4 of the circle. You can assume this. This is also quarter of circle. This is also quarter of circle. See, R is equals to rho L by A. You know this. See, if I have bended this wire, so rho is doesn't change. cross sectional area has not changed. If you
A
bend the
doesn't
wire,
change.
A doesn't change, so your R is proportional to L. So if you have bent into the circle, see, and you are talking, we are considering these 4 quarters. Are you getting my point? This is the first quarter, second quarter, third quarter, fourth quarter.
Yes,
It means the
yes,
length is uniformly divided into 4 parts, equal parts, 4 equal parts. So it means these all 4 quarters have 12 upon 4, so it is 3 ohm. This is also going to be 3 ohm. This A to D, this D to C should be also 3 ohm. This C to B, it's also 3 ohm, right? Is it okay till here now?
hmm,
Now, what will
yes,
happen when your current starts
yes,
flowing
sir.
here? See, suppose your current flowing from this point. When your current comes to this point, now he will realize that he has two options. See, one path is this one, right? And another path is this one, isn't it?
Ah,
Now he has two
yes, now
paths,
I
and
get
in
it.
this path he has total resistance of 3, 3, 3, 9. In this manner, he has total resistance of 9 ohm, and in this manner, he has a total resistance of 3 ohm, and both the resistors are in parallel. Are you getting my point? This A to this part, B
Yes,
part,
sir.
and 9 ohm and 3. So now you have to
Hmm.
find the parallel of 9 and 3. So it should be 9 into 3 upon 9 plus 3, that is the 12. So you should have this 4 jar, so 9 upon 4. So the total resistance of this circuit is 9 upon 4. You know, the total resistance of the circuit gets changed. It depends on at which point you are applying your source. The same, it doesn't mean that if your this 12 ohm is converted into a circle, your R equivalent will be 9 by 4 always. It depends at which terminal you are applying your source. I will discuss that also. See, so now I have the R equivalent is 9 upon 4. So now you can find the I equals to V upon R, and it should be V is how much? 36. R is how much? 9 into 4. So 9 4 ja, so its answer should be 16 ampere. Are you getting this?
Yes, sir.
Now,
16. Yes.
yeah, suppose I am saying that now I have applied my voltage source between A and C. I have applied my voltage source between A and C. Can you tell me what will be the R equivalent only? Can you tell me if your R equivalent is correct? Everything is
So
correct.
it would be R equivalent would be 3, sir.
Yeah, see here now R equivalent gets changed. That's I want to explain. It doesn't mean, see, you can't see like, you can't do like this, that if a 12 ohm resistor went into a circle, its R equivalent will be this. No, it depends on at which point you are applying your power or battery. Are you getting my point?
Yes, sir.
So there are a
Now,
lot of
yes, sir. Now
questions.
I
There are
understand.
many questions in this type of geometrical, formation. So we will discuss all those also. First, let us discuss your doubt.